Chapter 7 Permutation and Combination. Topic 7.0 Permutation and Combination. Subtopic 7.1 Permutation. Learning outcomes. At the end of the lesson, students should be able to A. Use the techniques of counting. B. List the permutations of a set of objects. C. Find the number of permutations of n different objects. D. Find the number of permutation of R objects from n different objects. E. Find the number of permutations of n objects comprising of R1 identical objects of type 1, R2 identical objects of type 2, until Rk identical objects of type K. Before discussing, firstly we have to understand a related technique, which is called the technique of counting. Technique of counting. Even an event or operation can take place in m ways, and for each of these, the second event or operation can take place in n ways, and then there is a total of m times n ways of events or operations that can take place. This technique is known as the multiplication principles. This principle can be extended to cover more than two successive events, where the total number of ways is given by m1 times m2 times m3 times m4 times ... until times mn. Example 1. In a computer game known as Maze of Tunnels, there are 2 tunnels leading from point A to point B, 3 tunnels leading from point B to point C, and 4 tunnels leading from point C to point D. Calculate the number of routes a cat can take to move from point A to point C via point B. B. From point A to point D via point B and C. Solution. This is tunnel A, tunnel B. We have 2 ways. B to C, we have 3 ways. And the number of ways to move from point A to point C via point B is 2 times 3 equals 6. And B, the number of ways to move from point A to point D via points B and C. Okay, from C we have 4 ways to D. So if you want to go, if a rat want to move from point A to point D via points B and C, is 2 times 3, 2 ways times 3 ways times 4 ways. So we have 24 ways. Permutations of a set of objects. A permutation is an arrangement of a group of objects in a particular order. The order of the objects is taken into consideration. Example 1. There are 3 pictures A, B, and C to be hung in a line along the wall. In how many ways can they be arranged? Solution. So if A, B, C, C, B, A, B, A, C, C, A, B, A, C, B, B, C, A. There are 6 ways of arranging the pictures hung on the wall. Each arrangement is called a permutation. technique of counting can be used to find the number of ways of arranging the pictures. That is, M1, we have three choices for the first picture. M2, two choices for the second picture, and M3 is one choice for the third one. So therefore, altogether, there are 3 times 2 times 1 equals 6 ways. Another method is by using boxes. Okay, so the first one, we have 3 ways, 2 ways the second one, and the third one we have 1 way. So therefore, the number of ways of arranging 3 pictures is 3 times 2 times 1 equals 6. Example 2. A shop stocks t-shirts in 3 sizes, small, medium, and large. They are available in 4 colors, black, red, yellow, and green. If the sizes are denoted by S, M, L, and the colors are denoted by B, R, Y, and G, make a list of all the different labels needed to distinguish the t-shirts and find the number of different labels. Solution: we have the t-shirt with the sizes of small, medium, and large. And then each size we will have colors B, we have R, Y, and G. And so for M, B, R, Y, G. And so for S, B, R, Y, and G. So these are the labels of the t-shirt. And therefore the number of different labels are 3 times 4 is 12. Permutations of n different objects. Number of permutation of n different objects taken all at a time without repetition is npn, which is equals n factorial over n minus n factorial. So we have n factorial over 0 factorial, which is equals n factorial. What is n factorial? That is n times n minus 1 times n minus 2 times ... until 2 times 1. Where we have npn equals n factorial, and we have 0 factorial is 1. So here we have 0 factorial is 1. So n factorial over 1 is n factorial. Example 3. How many different words or example can be formed from all the letters of the word logarithms? Solution. Since the word logarithms has 9 letters and all the letters are distinct or different, the number of different codes which can be formed is P as 9p9 equals 9 factorial equals 362880. Example 4. How many ways can 5 people be seated on 5 chairs arranged in a line if no condition is imposed and if the first chair is reserved for one particular person? Solution. The number of ways is 5p5. Okay, this one is 5 people be seated on 5 chairs arranged in a line if no condition. Okay, so we have 5 factorial, which is equals 120. Okay, and then to answer the second part, if the first chair is reserved for one particular person, so the first chair is seated by one particular person, so there is only one way. Okay, since there are 4 choices of sitting with 4 people left, the number of ways is 1, which is for the first chair is seated by one particular person, and this is the left behind one. We have 4 people left, and then 4p4. Okay, so 1 times 4 factorial equals 24. Example 5. How many different 4-digit numbers can be formed from the digits 5, 6, 7, and 8 if there is no repetition? B. The first digit must be 7 and no repetition is allowed. Okay, to answer part A, okay, we want to know how many different 4-digit number, okay, and from 5, 6, 7, and 8. Okay, the first one, the first box, we have 4 possible choices. Okay, 5, 6, 7, and 8. Okay, after taking 1, okay, the second box shall be 3 possible choices. Okay, then 2 already taken, and then for the third box we will have 2 possible choices, and the last one we have 1 only, so 1 choice. Okay, we have 1 possible choice, we have 1, so therefore the 4-digit number is 4 factorial, or 4 times 3 times 2 times 1 equals 24. Okay, now we go to answer part B. The first digit must be 7 and no repetition is allowed. Okay, if the first one, okay, we have 7. First digit must be fixed to 7. And if it is 7, we still have 3, we have 5, 6, and 8. So the second box must be 3 possible choices. And the third box is 2 possible choices because 2 already taken. And the last one is we have 1 possible choice. So we will have 4-digit number. If 7 must be the first digit, is 1, stand for this 7, times 3 times 2 times 1 equals 6. Permutation of R objects taken from n different objects. The number of permutation of n different items taken R at a time is n PR, where npr equals n factorial over n minus 1 factorial. There are 2 types of permutation of n objects taken R at a time. 1, with restriction or repetition are not allowed. So we have NPR. B, or the second one, with no restriction or repetitions are allowed. We have N power R. Okay, This is no restriction, or repetition is allowed with n power r. This one is repetition is not allowed, NPR. Permutation with restriction. Example 6. In how many ways can the letters H, A, S, M, and R be arranged without repetition when all the 5 letters are taken at a time? B. 4 of the letters are taken at a time. C. 2 of the letters are taken at a time. Solution. When all the 5 letters are taken at a time, the number of ways is 5p5 equals 5 factorial equals 5 times 4 times 3 times 2 times 1 equals 120. B. When 4 of the letters are taken at a time, the number of ways is 5p4 equals 5 factorial over 5 minus 1 factorial equals 5 factorial equals 120. C. When 2 of the letters are taken at a time, the number of ways is 5p2 equals 5 factorial over 5 minus 2 factorial equals 5 factorial over 3 factorial equals 20 ways. Example 7. Suppose you have 4 different flags. How many different signals could you make using A. 2 flags, B. 2 or 3 flags? Solution. A, N is 4 and R is 2 for the 2 flags. So we have NPR equals 4p2 equals 4 factorial over 2 factorial equals 4 times 3 times 2 factorial over 2 factorials equals 4 times 3 equals 12. Or you just go to use your calculator, 4p2, and you get the answer 12. There are 12 different signals using 2 flags from 4 flags. B. 2 or 3 flags. So you have your N equals 4 and R equals 2, or N equals 4 and R equals 3. So if it is or here, so we have to put plus. 4p2 plus 4p3 equals 4 factorial over 2 factorial plus 4 factorial over 1 factorial. So it is equals 12 plus 24 equals 36. There are 36 different signals using 2 or 3 flags from 4 flags. Example 8. 4 sisters and 2 brothers are arranged in a straight line for several photographs to be taken. How many different arrangements are possible if there are no restriction? B. The 2 brothers must be separated. Solution. Number of arrangement of 6 people, 4 sisters and 2 brothers. No restriction. Okay, we have no restriction for the first part. So we have 6 factorial equals 720 ways. B. 2 brothers must be separated. First, find the numbers of arrangements with the two brothers standing next to each other. In this arrangement, the two brothers move together as one unit, or we block the two brothers as one. And this is equivalent to the arrangement of 5 objects, except that they are able to switch positions with each other. Okay? So these are the two brothers, B1 and so B2, and 4 sisters. And altogether, we have this, what we call this as one block. Okay, this is one block, and we have 4. Altogether, we have 5 objects. Okay, this is 5 objects. And then inside this block also, when we block B1 and B2, they can switch position each other. So B1, okay, move to B2, and B2 move to B1. So therefore, number of arrangements with the two brothers next to each other is 5 factorial for these 5 objects. And these 2, okay, factorial stand for the interchanging of the position of these two brothers. So it equals 120 times 2 equals 240 ways. Example 9. Find the number of arrangement of 4 digits taken from the set 1, 2, 3, 4. Assuming no repetition, in how many ways can these numbers be arranged so that the numbers begin with the digit 1? B. The numbers do not begin with the digit 1. Solution. In general, the number of arrangement of 4 digits is 4 factorial equals 24. Okay? And A, if the arrangement begins with digit 1, then the number of ways of the 3 remaining digits can be arranged. Okay? Alright, this one is fixed to 1. And number of ways here is 1 also. And this is the rest of the digits, 2, 3, 4. So now, okay, then the number of ways, the remaining digits can be arranged. This is what we have to arrange, the 3 digits. So it is equals 3 factorial equals 6. Okay, or we have 1 times 3 factorial equals 1 times 6 is 6. B, the number of arrangements that do not begin with digit 1. So what we have to do is, we have 24. Okay, there is no condition. Okay, this is a general arrangement of all the digits is 24. And then we just go to minus. Okay, the arrangement which is begin with digit 1 minus 6. So equals 18 ways. Example 10. 4-digit numbers are to be formed from the digits 0, 1, 2, 3, 4, 5, 6 without repetition. How many numbers can be formed if the number is less than 5,000? Next, begins with digit 4 or 6. Then it's between 2,000 and 600. And the last one is it is an odd number. Solution. We go to, it is less than 5,000. We have to form 4-digit numbers. From, we have how many digits here? Okay, 0, 1, 2, 3, 5, 1, 2, 3, 4, 5, 6. We have 7 numbers. Okay, the first number in this 4-digit number must be 4, because we want this to be less than 5,000. So 0 cannot be included. 1, 2, 3, and 4. So we have 4 choices. So this will be the first box. And 1 is already taken. So originally we have 7 numbers. So we have extra 7 minus 1 equals 6. Okay, in the second box we have 6 choices. And then after that, 2 is already taken. And then left behind we have 5 choices. Okay, and then after that we have 4. So altogether we have, the number of permutations is 4 times 6 times 5 times 4 equals 480 ways. B begins with digit 4 or digit 6. Okay, we have to form 4-digit number. Okay, this is the first box. It's already fixed. Okay, if it is fixed to 4 or 6, so we have here 1, and the rest all the same. Okay, if it is begin with digit 4, okay, and then we have 7, okay, minus 1, that is minus number 4, so we have 6 ways. And we have 2, same thing here also, if it is begins with digit 6. So that's why we multiply by 2. And in the third one, we have 5 choices. And the fourth one, in the fourth box, we have 4 choices. Same thing for these boxes. Okay, for these boxes, same things. That's why we multiply or times 2. So we have 240 ways. And then now we go to the next one, between 2,000 and 6,000. Okay, remember that we have to form 4-digit number. If it is between 2,000 and 600, okay, in the first choice or the first box, we only have number 2, number 3, 4, or 5 only. We cannot go to 5 because we cannot go to 6, because if put 6 here, immediately we will have, because we will have more than 5,000. We want this to below 5,000, but more 2,000. So this will be choices. We have 4 choices for the first, and the second one, okay, we have 6 because 0 just now, okay, this one 0 is not included, is put into the list, the next list. We have 6, and then after that 5 and 4. So the number of permutation is 4 times 6. Okay, 4 is for the 2, 3, 4, 5. Okay, 6 here because originally we have 7 numbers. Okay, 7 numbers. So therefore, 1 is already taken, and the left behind 1 is 6. Okay, after that, 2 already taken, and we have 5 choices. And then 3 already taken, and we have 4 more choices. Okay, this is the first digit, second digit, third digit, and the fourth digit number. And we have 480 ways. Okay, this will be the last part. It is an odd number. The odd number, we have to go to the last digit. The last digit, okay, must be 1, 3, 5. Okay, to make this 4-digit number become an odd number. So we have 5. Okay, after taking 1, on the last digit here, we still have 6, but then, okay, the first one cannot be 0. So just now we have 6, and then 0 cannot be put in the first place here, so we only have 5 choices. And then in the second part here, okay, the second digit number here, we have 5 also, okay, because 0 is already added, okay, into the second place, and the third place is 4. And then the number of permutation must be 5 times 5 times 4 times 3. 3 for the last digit. Okay, it can be 1, 3, or 5. We have 3 choices, okay, for the last digit. So altogether we have 300 ways. Permutation with no restrictions. Example 11. How many 3-digit numbers can be made from integers 2, 3, 4, 5, 6 if each integer is used only once? Number 2. There is no restriction on the number of times each integer can be used. Solution. Okay, now altogether we have n. Okay, we have n is 5. 1, 2, 3, 4, 5 integers. And we want to form 3-digit numbers. So therefore r equals 3. So we have NPR of 5 P3, okay, equals 5 factorial over 2 factorial equals 5 times 4 times 2 times 2 factorial over 2 factorial, and this one can be cancelled, and we have 5 times 4 times 3 equals 60. So there are 60 different arrangements. Okay, part 2, number of ways of making the 3-digit numbers. Okay, because here no restriction on the number of times each integer can be used. Okay, no restriction. So we have 5, okay, and then taken one from these 5 choices, okay, and then put it back before we take the second one. Okay, on the second digit we still have 5 choices. Okay, after taking one out and then put it back because repetitions is allowed, and then we take the third one, okay, the third digit. So altogether we have 5 times 5 times 5, we have 125 ways. Example 12. In how many ways can 4 girls and 5 boys sit in a row if the boys and girls must sit alternate to each other? Solution. We have boy, okay, must be sitting alternate to the girl. So this one is girl, boy, girl, boy, girl, 5 boys. Okay, and girl, 4 girls. Okay, so 1, 2, 3, 4 girls and another boy. Okay, and the number of permutation is 5 stand for 5 boys. Okay, 5 factorial, and 4 girls. Okay, 1, 2, 3, 4 factorial, because they still can switch the position of each other. So for the boys we have 5 factorial, and for the girls also we have 4 factorial. You can switch the position of each girl there. So we have 2000 880 ways. Example 13. 3 married couples have bought 6 seats in the same row for a concert. In how many different ways can they be seated with no restrictions? Okay, this is general position. Okay, they want to sit for a concert. Okay, B, if each couple is to sit together. C, if all the men sit together to the right of all the women. Okay, solution. This is the general sitting of 6 people. Okay, they can sit anywhere. So we have the number of permutation is 6 factorial, or 720 ways. Okay. B, if each couple is to sit together. Okay, so this will be the first couple, the second couple, and the third couple. And the number of permutation is 3. Factorial stand for, this position, or they can switch the position, okay? But it will still stick together for each couple. So you have 3 factorial. But inside here, they still can change position left and right for the H1 and for the husband and wife, okay? And this is husband and wife, the second husband and wife. They also can be changed, interchanged the place, okay, for left and the right. And so for the husband, the third husband and wife, still can change the position. So we have 2 factorial times 2 factorial times 2 factorial. Altogether is 48 ways. Okay, see, if all the men sit together to the right of all the women. So we will have here, this is all the men to the right of the women. Okay, so this is the husband one. Okay, H1, H2, H3. Okay, this position is fixed like this because the men sit together to the right. Okay, so this is to the right of the women. So we'll have the number of ways is 1 because this position is, it cannot be interchanged. It is fixed already that husband must be always on the right of the wives. So 1 times 3 factorial for the interchanging the position of these 3 women, okay, or 3 wives. And this 3 factorial is the interchanging of the husband, okay, the 3 husbands, okay, they can change inside. So here it is equals 36. Example 14. There are 10 students, out of whom 6 are females. Find how many arrangements are there if they are arranged in a row. B, males always sit on one side and females on the other side. Solution. The number of permutation we have altogether is 10 students. Okay, 10 students. But here they arrange in a row. Okay, no conditions is imposed here. So this is general, they can sit anywhere. And then we will have here the number of permutation is 10 factorial equals 3628800. B, we have 6 female and altogether is 10, so therefore males are 4. Okay, and males always sit on one side. Okay, this is general. Also, one side, it can be on the left or on the right. Okay, so that's why we have to times this 2 factorial, because they can sit, the male can be on the right or can be on the left. So the permutation is 2 factorial, stand for left or right of the male. Okay, and 6 people, female also can interchange the places, and so for the male, they also can change the places or the position. So therefore, altogether this is 2